let's go back. Let's see, today is October 5th. And what we want to specifically talk about today is linear graphs. We'll eventually say functions. We're getting there. Okay, linear. Linear. So linear is kind of a fun word because it means straight. And if it's not straight, you can't call it linear. It has to be a straight line or dots in a straight line. But linear really means straight. So linear means straight. Curvy lines are nonlinear. Okay? Now domain. Domain are all possible x values. We talked about this yesterday. Domain are all possible x values of the graph. Domain is how wide. Does that make sense? It's the width of a graph, because those are the x values. Okay? The range is all possible y values. All possible y values. Okay? So here's what I say. I've seen this for years. Kids still know, okay? Ready? It's my domain. This way, don't mess with my domain. Which way am I going? Horizontally, right? Don't mess with my domain. How wide is my domain? That's my domain. And you reach for your range. Really easy to remember, right? You reach for your range, don't mess with my domain. Okay? So if I determine the domain and range of the first two examples, in the first example, there's no in-betweeners. There's nothing in between, correct? So the domain of this one is simply going to be, and I like set notation. That's what I like. See that little set symbol? It's a little brace, a little squiggly. It kind of looks like this. I don't draw it very well. Oh, I still didn't draw it very well. Oh, there we go. That's what it's supposed to look like. So it will never look that good again, okay? But that's kind of what that's supposed to be. So the domain in this case, it has a point here at 0, -2. It has a point here at 1, -4. I don't think that's negative. I think that's positive. It must have copied off weird, huh? Because negative doesn't go that way.
The way it's cropped makes it look negative.
It does. Well, that's definitely got a positive. That wouldn't make any sense, right? Here we go. Yep. So at this point, the x value is 1. At this point, the x value is 2. At this point, the x value is 3. At this point, the x value is 4. At this point, the x value is 5. And then we get a 6 and 7. That is the domain. There's no 1.2. There's no 2.3. There is no -1. Those are the x values of those points. Thumbs up? Good. And the range is just the y values. And again, let's see how good I can do my set. Okay. So it has a y value of 2, 3, a y value of 4, a y value of 5, 6, 7, and 8. That's more like my normal brace symbols, okay? Thumbs up on that. Domain, just x values. Range, y values, okay? Now, second example is different because it's everything in between. We can have a 1.3. I can have a 4.5. I can even have a pi. Pi is even in here. 3.14, that's even in there, right? All these numbers. So we're going to say the domain. I'm going to write it in set notation like we learned in our last chapter. I'm going to go 0 is less than or equal to x, which is less than or equal to 6. Okay, 0 is greater than, so it's in between 0 and 6. X is greater than 0 and less than or equal to 6, and everything in between. See how we wrote that in set notation? We've done this before, right? And then the range, we'll do the same thing. I mean, there's all these values. I mean, it's a straight line. There's all these points are taken up, so on my range, I'm just going to go, let's see, 2 is my lowest, so I'm going to go 2 is less than or equal to y, because y value, which is less than or equal to 5, and everything in between. So there's my domain and range in set notation. How's that? Pretty easy? And we have to do it this way because there's all these values in between. This one was different. There's no values in between. These are just the values. Okay? Example 1. Graph these points, and I don't identify the domain. Well, this is pretty easy. Let's see. -2, 4. -1, 3. 0, 5. 1, 6. And 3, -2. First of all, not linear. No way. Not linear at all. That one's definitely linear, and this one's linear also. Right? Linear, straight line, straight line. Linear, straight line, okay? That one's not linear. It's all over the place. But we can identify the domain. That's easy. It's just going to be the x values. So the x values, here they are. -2, -1, 0, 1, 3. Just as easy as that. -2, -1, 0, 1, 3. All right. -2, -1, 0, 1, and 3. And the range is all the y values. Well, that's my 4, my 3, my 5, my 6, and my -2, okay? It does not have to be in order, but it's better if it is. So I might say, this kind of bothers me a little bit. This is okay, I would never mark this wrong. But we might say -2, 1, 3, 4, and 5. Just looks better because it's from smallest to biggest, okay? You don't have to do that, but it's just better. Okay, pretty easy? Easy today? Yeah, Bailey?
Isn't that 1 of 6?
Did I miss one?
Yeah.
4, 3, 5, 6. Thanks, Bailey. Oh, thanks, Bailey. Have you ever known me to make a mistake? Yeah, all the time, right? Pretty much. I know I need a retake right now, huh? There we go. Thanks, Bailey. Okay, now it makes more sense, right? Turn the page. Guess good? Okay, define linear function. So a linear function is a straight line. It doesn't have to be a line, but a straight relation where every x value has exactly one y value. And we talked about that yesterday, right? So I'm going to highlight a few things that are important to us, right? So let's see, I'm going to highlight. Let's go and find my. So straight, that's linear, right? And if it's a function, every x has exactly one y, right? So determine if the table makes a linear function. Okay, now, two ways to do it. One is we just graph it, and if it looks straight, we can do it. Now that's the long way. This one we can do. We can make a graph, right? Get out a piece of graph paper. Right, we go 1, 5, 2, 10, 3, 15, 4, 20, right? That will work. It will work. it means you gotta take out a piece of scrap paper, right, and then you gotta go ahead, dot, 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 see if it's straight. So you can do a test, and you forget what I'm gonna tell you here in a second, that always works. Now, or, if it's linear, it's gotta go up by the same amount each time. If it's linear, it's gonna go up by the same amount each time. So, it goes up by 5. Goes up by 5. Goes up by 5. So as it goes, it's like stairs. As it goes over 1, it goes up by 5. Over 1, it goes up by 5. Over 1, it goes up by 5. So this is definitely going to be linear. Second example, well, let's see. It's going to go up by 2, up by 2, up by 2. So it's going up by 2s. Then it goes up by, how much is this one going up by? 6. And up by 2. And then up by, yeah, that doesn't look right. And you know what? I'm going to graph it. That's definitely no. But if I'm still in a test, I'm kind of confused. Let's see what it looks like. Okay, so if I just, let's see if I can make any sense out of this thing. So if I went 5, 1, 2, 3, 4, 5, negative 9, 1, 2, 3, 4, 5, 6, 7, 8, 9. I went 7 and negative 3. I went 9 and negative 1. I went 11 and 3, right? That does not look straight, does it? That does not look straight. But I knew it because it went up by different amounts each time, so it's not linear, okay? Now we did this in our warm-up, right? So using a t-table, make 4 points and graph this line. All right, so if you're going to make a t-table, you need 4 points, and you can choose. Okay, you can choose. You're going to make a t-table. It doesn't matter. Okay, now think hard. Think hard. So the line goes forever. Do you agree with that? So if you can pick the easiest points, make part of the line, and the rest of the line goes. Correct? You can pick any 4 points. What 4 points do you want to pick, Artie?
I would probably do 0, 1, 2, 3.
That's what I would do too, right? Now you can do other points, by the way. You can. I agree with Artie. So let's pick 0, 1, 2, 3. You could pick any points, but why not these? So what happens is you're going to plug in, instead of x, you're going to go y 0 minus 3. So 0 replaces x. 0 minus 3 is a negative 3. And then you're going to go y equals, plug in the next value, 4x, right? So I get a 1 minus 3. 1 minus 3 is a negative 2. Okay, then plug in 2. 2 goes in for x, so it's 2 minus 3, which is a negative 1. Okay, then put the 3 in for x. 3 minus 3 is 0. Okay, these are points. So I'm going to have, let's see, I'm going to have 0, negative 3. 0 over 0, down 3. Over 1, down 2. Over 2, down 1. Over 3. Okay, so far so good? This is, now, Artie, you pick 0, 1, 2, 3. Could I pick 1/2? Could I pick negative 4.53? Yeah. Could I pick 145,673? Yeah. So what I'm going to do is connect the dots. Because those others are there, right? I'm just going to connect the dots because they're really there. We just chose not to plug them in because what a pain, right? I'm going to plug those in. Let's pick with Artie. I like Artie's idea. So I'm going to connect the dots. So if I connect the dots, then every single point is in there, okay? Now, this is a continuous function because it continues. There's no gaps. So continuous means that there are no gaps. That's the easiest way to know continuous. Draw a picture. Well, that is right there. That's my picture. That's continuous. Discrete. Discrete is going to have gaps. We'll have gaps, stops, jumps, whatever you want to see, okay? That is discrete. Do you see why it's discrete? You got to jump. You got to jump. It doesn't flow. I had one teacher tell me a long time ago, he said if you have to pick up your pencil to draw it, it's not continuous. If you have to pick up your pencil, on this one, that's continuous. Now it stops there and stops there, but it's continuous. Does that make sense? All right, that's all I have. Pretty easy for today. All right, I'm going to stop my recording.